Let's start with the first question. So the first question is from, I took this from this 2024 prelim paper lah. So some of you may come across the question. I think the first one should be from ACJC. Okay, at the ski resort, the engineers are doing this. So when you see the diagram, try not to see the diagram now, huh? You should see as lines and planes and points, that's all. So blah blah blah, the whole first paragraph, not really important. Okay, the cable has this equation, lambda is -5 to 15. There's a parallel CD that passes through this point. The plane is this. Find the distance between AB and CD. So what I will do, we will draw two straight lines that are parallel. Okay, one is your AB and then one is your CD lah. So this one is called line AB. Okay, I know nothing about the line CD, but I know that CD contains the point 3, -18, 10. Okay, so when you want to find distance or anything in your lines, always try to form your right angle triangle because that's what you need. Okay, so how to form a right angle triangle? Just like that. Oh. Okay, then you need a point here. What? So what is the only point that you know here? From the equation, you know that the point 5, -5, 7 is on the line AB. So what we do, we label this X, we label this Y lah. Okay, so from here, which are the two direction vector that you can find? You can find the direction vector of XY. You will know the direction vector of line CD. Okay, what's the direction vector of line CD? Line CD is parallel to AB, so it has the same direction vector as AB. So if you have these two direction vector, this is the theta that you have. And they want you to find this length. So you use your Picasso law. Okay, so XY is just equals to -5, 5, -7 plus 3, -18, 10. This will give us -2, -13, 3. Okay. So now I have this direction vector, I have that, then I now will apply my Picasso. So sine theta equals to opposite over hypotenuse. The hypotenuse is my length of xy. Okay, so sine theta, what do you do? Sine theta is your cross product. -2, -13, 3 cross our direction vector of CD, which is -2, 2, 3 over the length of xy and the length of the direction vector. So when we simplify this whole thing, you can see that the length is just equals to crossing of this over the length of the direction vector, which is 2 square plus 2 square plus 3 square. Okay, so L is equals to, when you cross this, what do we have? -39. So funny, where the number? -39 -45. -6, 0. -4 -30 over square root 4, 8, 17. Okay, what is your square root 45 square plus that? Square root 2925 over 7, square root 17. 2925 can divide by what? Somebody with a calculator that can do for me better, more efficiently. Can be divided by 25. Can be divided by 9. So it's 15 square root 13 over square root 17. Okay. Any questions so far? Okay. So that's the distance between your line AB and CD lah. I move on to the second part. The length of the cable from point A to point B is 100 units. Find the length of projection of AB onto the slope. So what I will do, I draw a slope out. Okay, then I draw my AB. Okay, so what we will do, we will draw dotted line down. So the length of projection of AB is this red color line. Okay, and this red color line is actually equals to this red dotted line. So again, I will use Tuakaso and all this to find. So which are the direction vector that I have? I have this direction vector. I have this direction vector. So this is the theta that I would have. Don't use theta lah. We change back to other alpha lah. This is the angle that I would have. Okay, so now to find this L, don't use L already lah. We use H lah. To find H, what should we do? Again, we should use sine theta lah. So sine alpha equals to H over hypotenuse. Okay, and what is sine alpha? Sine alpha is just AB. AB just has the direction vector of the line cross the normal vector of the plane, which is 1 minus 2, 3, over the length of AB and the length of the normal vector. Do like that cannot. I got this. Find the length of the cable. Wait, wrong. Wrong. 错了. I cannot do this. This is AB. I cannot just take the direction vector. What should I do? Okay, don't do like that. Sorry. Don't do like that. We cannot do like that because I do not know what is vector AB. I cannot just take the direction. Okay. But what we can do is we can actually find the angle alpha. Okay. So how to find angle alpha? We just use the angle between two lines, which is cosine alpha equals to the direction vector of AB, which is negative 2, 2, 3, dot the normal vector 1, negative 2, 3. We modulus so that we're finding the acute angle over the square root of 2 square plus 2 square plus 3 square, square root of 1 square plus 2 square plus 3 square. Okay, so cosine alpha is equals to -2 -4, 5. 5 over square root 17 square root 9, 10, 14. Okay, so alpha equals to cosine inverse 5 divided by square root 17 times 14. It will give me 71.08883 degree. So now you have this angle already, and you have the line A, you have the length AB. You can just use your Picasso. So sine alpha is equals to H over the length of AB. They give you that the length of AB is 100. Okay, so now you put alpha in, so H is equals to 100 sine alpha. They never say exact value lah, so don't need to bother too much. So 94.6022, that will be 94.6 units. Okay, any question? If they want exact value, then how? Then from here, you need to go and draw your triangle. This is your alpha, this is your adjacent, this is your hypotenuse. 17 times 14, square root 238. Then you have to use Pythagoras to find this. This should be square root 213. Yeah. Okay, then you use this triangle, you will get that loss square root 213 divided by 223. Yeah. Oh. Okay, so far okay. Next. Part 3. Oh my goodness, 15 minutes go through 3. Find the coordinate of P on the cable AB such that the perpendicular distance from the slope is this. So again, I draw a slope. So I try to make the plane the horizontal one. Then this is my line AB. So I got a P here. What's so special about this P? This length is 2 square root 14. Okay. So since P is on the line AB, I can write OP as 5 minus 2 lambda minus 5 plus 2 lambda and 7 plus 3 lambda. Again, I want to form a right angle triangle, so I just choose a random point on the plane. I call it Q. So how do we find Q? You know your plane has this equation, x minus 2y plus 3z equals to 5. So as long as any coordinate satisfy this equation, it will be on the plane. So I say I let Q be 5, 0, 0. That's the easiest you can come up with. Okay, so from here, again, you see I need to identify which two direction vector I have. I have this direction vector, I have this direction vector, means this is the angle that I will have. I call it beta. And you also know that this length is 2 square root 14. Okay, so what we do now is we can find our PQ. PQ will be equals to minus 5 plus 2 lambda, 5 minus 2 lambda, minus 7 minus 3 lambda, plus Q. What is Q? Q is 500. This will give us 2 lambda, 5 minus 2 lambda, minus 7 minus 3 lambda. Okay, so now in order to link to 2 square root 14, I will use cosine. Cosine beta is equals to 2 square root 14 over the length of PQ. Cosine beta is what? Cosine beta is just PQ dot the normal vector of the plane. Remember to put modulus because we are finding length over the length of PQ and the length of the normal vector. So from here, the PQ will cancel. Then we will just solve this. So this is 2 lambda minus 10 plus 4 lambda minus 21 minus 9 lambda. Got the modulus there over. This is the square root of 1 square plus 2 square plus 3 square. Okay. So 9 square plus 2 square plus 1 square is square root 14. So we have this. After that, we will have negative 3 lambda minus 31 is actually equals to 28. Okay, over here, something that you need to take note, the modulus is still there. When you remove the modulus, please do both parts. So this is equals to 28 or this is equals to negative 28. So negative 3 lambda equals to 59. Lambda equals to negative 59 over 3. Over here, negative 3 lambda equals to 3. Lambda equals to negative 1. Okay, we reject this because from the start, the question says lambda is between negative 5 to 15. So we sub this into P lah. So P will just be 5, 7 minus 7 and 4. Okay, you can see whatever that I've been adopting is all using Tokaso. Any questions so far? All good. Okay, let's move on to the next one. Question part 4. There is a viewing gallery on the mountain that overlook. The engineer wished to install a huge glass panel. The window plane is perpendicular to that and parallel to that. Given that this is on the point, find the Cartesian equation. So to find the equation of the window plane, which is just equation of plane, we need two direction vector on the window plane. And what are the two direction vector? First thing, they say that the window plane is perpendicular to the ski slope. So when they say window plane is perpendicular to the ski slope, means the normal vector of the ski slope is on the window plane. Okay, next it say parallel to AB. That means the direction vector of AB is also on the window plane. So we have two direction vector that is on the window plane already, plane. So we know that the normal vector of the window plane can be found crossing the direction vector of AB and the normal vector of 6, 12, 4, 10, 4, 2, 6, 12, 12, 18, wrong 3, 9, 20, negative 24. Okay, so the equation of window plane will just be r dot the normal vector equals to the normal vector dot a point on the window plane, and they have given us 10, 10, 20. So this is 120, 210, 250. So writing as Cartesian form. Okay, any question? No, then I move on to the next part. Part 5. Due to a power shortage, the cable car got stuck on AB at a point Q with this. So this is again the ski slope. Oh my goodness, why they cannot draw the parallelogram? Okay, so again, a point on AB, which is our Q. Oh my goodness, I should not have used Q just now. They ask what is this distance. So this point I can call R, F lah. So this is actually just the foot of perpendicular of a point. So we know that the line QF, I can form this equation. It has the point and the direction vector is the normal vector of the plane, 1 minus 2, 3. Okay, since OF is on the plane, then we know that OF is on the line, sorry, so we know OF can be written as this. Okay, then how to find? So we know OF is also on the plane, so when we take this, dot the plane, it must be equal to 5. So what do we have? We have 14s equals to 5 plus 7 plus 14 minus 75. Negative 49. So S is equals to negative 7 over 2. So F will just be minus 7 over 2 minus 21 over 2. 7 plus 7, 14. 25 minus 21 over 2, 29 over 2. Okay, so that's all for question 1. Any questions so far? Good.
Yeah, how you know they asking about foot of perpendicular?
Nearest what? Where else can be nearer? Correct. Okay. So yeah, part of the skill is to interpret what they want. I move on to the next question. Wow, 30 minutes on one question. My neck is breaking. Ugh. Question 2. Wow, iPad is so wonderful, yeah. Can do like that. Refer to the origin. The point A, B, and B, C have position vector this. Show that this is a vector perpendicular to the plane. So how do you know this is a vector perpendicular to the plane? How? How do you show that this is a vector perpendicular to the plane? What do? We first find. So basically this means that this thing is the normal vector of the plane, which makes absolute sense. But how do you show it? biggest question mark. So what you need to do is to show that this thing dot the direction vector of the plane, you must get 0, correct? So you must interpret all this out. So perpendicular means 0, so you have to try to form it out. So we first find what? We find AB log. So AB is what? AB is equals to B minus A. Then next we find AC. You want to find any two direction vector on the plane also can. This will be C minus A. Okay, then we now know that the normal vector is just equals to AB cross AC. So when we do this, our vector must be parallel to that. Okay, so B minus A cross C minus A. What do we get? We get B cross C minus B cross A minus A cross C plus A cross A. We know that A cross A is actually the 0 vector. So this is actually B cross C. Okay, then this one we change to A cross B. When we change to A cross B, we change the sign. This one change to C cross A. Okay, A cross A is just 0 lah. So equals to what they want there. A cross B plus. Okay, since normal vector is perpendicular to the plane, comma, this is perpendicular to the plane. Okay, if you take let's say AB cross BC, you will also get the same thing. So don't need to worry which two do you actually choose. Okay, 2B, prove that the equation of the plane can be written as this. Clearly explain the reason. So to form the equation of plane, we already know that the normal vector is that. So I can just write that down. R dot this. And to find the D, you actually need to take the normal vector dot a point on the plane. In this case, we will do A. Why would I do A? Because the question over there put A dot B cross C. You can take other letter, but you will not be able to show that. Okay, so just expand that side. So this will become A cross B dot A plus B cross C dot A plus C cross A dot A. Okay, over here, these two things is actually equals to 0. How come? You remember that what I always say, if you take 1, 2, 3 cross 4, 5, 6, you will get 12 minus 3, 6, negative 3. Remember what I say, your final answer that you cross, how to check whether the cross is correct? When you dot 1, 2, 3, it must give you 0, because when you cross, you are trying to find the vector that is perpendicular to the original 2 vector. So when you take A cross B dot A, it will become 0, because A cross B is like your new one. Then you dot back the original one itself, so you get 0. Okay, so you need to explain a bit lah. Since A cross B is perpendicular to A, and C cross A is also perpendicular to A cross B dot A is equal to C cross A dot A, which is equals to 0. Then you have what they want. Okay, any question? No, a bit complicated lah. You must really know your concept very well. Okay, let's move on to part C. Given that A is this, B is this, show that the equation of plane can be written as this. Hence, find the Cartesian equation of plane that are distance 5 units. Okay, so based on the previous equation, we just put in, no? So 1, 0, 0 cross 0, 1, 0 plus 0, 1, 0 cross 0, 0, 1 plus 0, 0, 1 cross equal to A dot B cross. This is just 0, 0, 1. This is just 1, 0, 0. This is just 0, 1, 0. Okay, so done. Hence, find the Cartesian equation of the plane which are a distance of 5 units from this plane. So remember, this one I don't know I say how many times already, but you always don't get it. So in order to find the best place is always origin. When you measure something, always measure from the origin. So this plane, we must first find out this plane, how far away is it from the origin. Before we can find how far away from the origin straight from the equation, you must change this to a unit vector. This part must be a unit vector. So what do? We divide by the length. So divide by 1 over square root 3. Here also divide by 1 over square root 3. So based on this equation, we know that the distance of this plane from the origin is actually 1 over square root 3. So what are the other equations? So they want it to be 5 units from this plane. So the first equation, plane 1, okay, it will be this one. So it will be this one plus 5 lor. Okay, because you need to be further 5 unit away. So like this is the plane. So if it's another 5 unit away from the origin, 5 unit from this plane, that means it's 5 plus 1/3 units from the origin. So we change this equation first. So I times square root 3 throughout to make it nice back. Then this will be 5 square root 3 plus 1. Okay, then your Cartesian equation for this will be x plus y plus z equals to 5 square root 3 plus 1. Okay, then what is the other equation? Other than being 5 units from here, it can also be 5 units from here. Correct, this can be your 5 units. Sorry, this can be your 5 units. So how to get that one? Instead of subtract addition, we subtract. So now times square root 3 throughout, so that it's easier for us to write the equation. So x plus y plus z equals to 1 minus 5 square root 3. Understand? I think we only have time to complete one more question.
Oh, why must you use the unit vector thing?
I don't know, I explained this one how many million times already.
Oh, your explanation not good enough. I don't understand it.
2y equals 3x plus 5. Does the 3 means anything? Huh?
What?
Does the 3 means anything?
Like twice of the gradient.
What?
Is it it's times
Does 3 means anything first or not? Don't talk about anything. Does 3 means anything?
no.
No. What do you need to do in order to make it mean something?
Divide by 2.
You need to make it 1y. Same thing. You need to make it 1. You need to make it unit vector. Then this number here makes sense.
What would that number mean?
The distance from the origin.
Oh,
You don't change that to unit vector. This 1 does not make any meaning. Same as this 3 here.
wait.
So that is the only way for you to compare the distance of two planes. Why we don't write as unit vector is because when you write as unit vector, the numbers are not nice. Would you prefer to write your Cartesian equation as square root 3x plus square root 3y plus square root 3z? 1 over equals to 1 over square root 3.
Nah.
Nah, even though this 1 over square root 3 means something, you will not like to write in this way, right?
Yeah.
Yeah, so that's the reason why we don't always write that as unit vector. Only when we need, we change it. You can see I change it to unit vector. In the end, I still change it back to non-unit vector in order to write it nicely.
Mm.
Okay. Next question. This is from ASR. Quite clearly. Got time to finish? Sure got time. We'll drag on. With respect to origin ABC, show that the Cartesian equations containing ABE is this. So to form the equation of the plane, we need two direction vector on the plane. So you either use AB, AE or BE. Okay, so just use AB lah. So AB is just -2, -3, -4 plus 657. That will give me 4, 2, 3. Then I find my AE, -2, -3, -4 plus 560, 5610. Here will give me 3, 3, 6. So the normal vector of plane is equals to 4, 2, 3 cross 3, 3, 6. We will get 3, 9, minus 24, minus 15. 12, 6. Okay, take out a number so that it is nicer to write. So we now know that R dot, the equation of plane, will simply be R dot 1, negative 5, 2 equals to 1, negative 5, 2 dot a point. I use back 2, 3, 4. How to check whether this is correct? You can either put point B or point E here. They must give you the same number. If you put point B and point E, they give you different number, means your normal vector is incorrect. Okay, so this is equal to 2, negative 13, negative 5. They want the what? The Cartesian equation. So x minus 5y plus 2z equals negative 5. Okay, this is a routine question. You should know how to do. Next, part B. A line passes through D and the midpoint M of CE. Find the vector equation of DM. So first thing first, you want to find equation of DM, you need the direction vector DM. So you have to find M first. So M is equals to EC, is the middle of EC. So 8 plus 5 over 2, 9 plus 6 over 2, 6 plus 10 over 2. So we have 13 over 2, 15 over 2, and 8. So now we find DM. So DM is equals to negative 4, negative 7, negative 3 plus 13 over 2, 15 over 2, 8. That will give us 5 over 2, 1 over 2, 5. So line DM, use point D, nicer, 473 plus lambda. I write 5, 1, 10. Okay, this one I take out half. Become 5, 1, 10. The purpose is just to make the direction vector a nice number. If you are not comfortable with that, it's okay with you leaving as 5 over 2, half, and 5. Part C. Find the exact coordinate of the foot of perpendicular from M to the surface found in part 1. So M coordinate is what? 13 over 2. In this case, if you want to write decimal, I think it is better for you. Write 6.5, write 7.5. It may be easier for you to interpret the whole thing. And less likely a careless mistake will happen. Okay, so let's call this foot of perpendicular F. So we find the equation of line MF first. Okay, I write in decimal better. 6.5, 7.5, 8 plus mu. So the direction vector of the line MF is just the direction vector of the normal vector, which is this. Okay, since F is on the line, we can write OF as 6.5 plus mu, 7.5 minus 5 mu, 8 plus 2 mu. Okay, and we know that OF is on the plane, so I will take 6.5 plus mu, 7.5 minus 5 mu, 8 plus 2 mu, dot 1 negative 5, 2, it will be equals to negative 5. Six 6.5 plus mu minus 37.5 plus 25 mu plus 16 plus 4 mu equals negative 5. I would have 30 mu that equals to negative 5 minus 16 plus 37.5 minus 6.5. 10. Mu equals to 1/3. So F will just be, oh my goodness, 6.5 plus 1/3. This one better see in fraction already. 13 over 2 plus 1/3. 39, 41 over 6. 15 over 2. You read wrongly. No. 15 over 2 plus 1/3. 47 over 6. Lastly, 8 plus 2/3. 26 over 3. Okay, hence find the shortest distance from M to the surface found. So we have to find MF. So MF is equals to M is what? MF is just what? MF, M is the midpoint. MF is just negative 13 over 2 minus 15 over 2 and 8 plus, what is F? F is actually 13 over 2 plus 1/3. 15 over 2 minus 5 over 3 and 8 plus 2 over 3. This one got minus. So it is just equals to 1/3 minus 5 over 3 and 2/3. So the length of MF equals to square root 26 30 over 9, which is equals to square root 10 over 3 units. Okay, next, part E. Verify that verify the line DM intersect the surface area found at point P with this. Hence, find the reflection. Okay, so I write down my DM first. DM is what? Five one ten. The surface is what? The surface is okay. How we verify? So actually, they already tell you, they just verify. So what we do, we sub 9, 8, 13 into the line DM lah. So 4 plus 5 lambda, 7 plus lambda, 3 plus 10 lambda equals to this. So lambda equals to 1. Okay, so you have a lambda that fits everything. So therefore this is on L line DM. Okay, next we also sub this into the surface. Then we will have 9, 8, 13 dot 1 minus 5, 2. This will give us 9 minus 40 plus 26 equals to -5 equals to right hand side. So therefore, this is on the surface. So if it's on both, this will be the intersection of line DM and the surface. Okay, this answer the first part of the question. Hence, find the reflection. The new page. Okay, so this is the surface. This is the line DM. This point here is our point 9, 8, 13. Okay, so when this red color line get reflected, it will look like that. To find the equation of the reflected line, you need 2 points on the reflected line to get your answer. Okay, from the previous part, you have already know that this point I can call as this line DM. So this point I can know as M, which is 6.5, 7.5, and 8. And we have found in part C that there is a point F here that is 41/6, 47/6, and 26/3. So from these two information, what we can find is we can find M prime. So if I have M prime and I have 9, 8, 13, I can find the direction vector of the blue color line. So how to find M prime? So X is just equals, 6.5 plus X over 2 is equal to 41/6. So 13/2 plus X equals to 41/3. X is equals to what, the 82 minus 39. 43/6. Then how to find Y? 7.5 plus Y over 2 equals to 47/6. Oh dear. Maybe I will forget it. -94 minus 45. 49/6. Last but not least, Z plus 8/2 equals to 26/3. 52 minus 24, 28/3. So M prime, M prime is equal to 43/6, 49/6, 28/3. This is not the worst numbers that I have seen. I think at ASR 2023, the numbers are even worse than this. Okay, so now I can find the direction vector of the reflected line. Which is just equals to this subtract away the 9, 8, 13. What the hell? Minus 54. minus 11 over 6 1 over 6 39 minus 11 over 6. So this one you can take out 1 over 6, you get minus 11, 1 minus 11. Okay, so finally, therefore, this one shift here a bit. So therefore, the equation of the reflected line of DM is just equals to R dot, no, sorry. The point I use 9813 nicer, plus alpha negative 11, 1 negative 11, where alpha is an element of real numbers. Any question so far? Let me stop the recording first.